Hello everyone, welcome back to my channel. In the last video we discussed about linked list. We discussed what is a linked list, why was it required, and how exactly is a linked list created. Right? In this video I'll be talking about the types of linked lists that we have. Right? So without any further delay, let's get started. So primarily we have two type of linked list. One is called a single linked list and the other one is called a doubly linked list. Right? Now both of these linked lists have a hybrid version of them. The single one is simply called circular linked list and the doubly one is called doubly linked list. I believe this doubly was added just to differentiate, right? So basically these are now your four type of linked list that you're going to study in the linked list world. Okay, so now let's talk about what exactly is the difference between them. So singly is the most basic one and the most commonly used one. This is the one that we saw in our previous video. So this is a classic example of a single linked list and adding it at null. Right, this is a single linked list. Now talking about doubly, as you can see, singly has basically two fields. One is the data field and the second is the address field. Right. Now what about doubly? Doubly has, instead of two, it has three fields. Okay, and in this the center field, that is the data field, and the first and third field, they're the address field. This provides you the ability of moving both forward and backward in the doubly linked list. In singly you can only move to the forward direction, but in doubly, because you have the address of a previous node, you can even move backward. So that is the advantage of doubly. However, it's a trade-off, remember, because now you need extra memory. You'll be consuming extra memory to store the address of the previous node. Okay, and yeah, it will also end at this. How do you identify what is starting? You have a pointer that is called as the start pointer. Yeah, so that is same in the both start and doubling. Now what about the circular linked list? So yeah, this is going to be a bit tricky. We are talking about circular, that is the hybrid version of syncing. So again, it'll also have the two address field. So you have DA and then you have your starting pointer, right? And let's create again three nodes, same manner, DA and then DA. Now here comes the change. Here, let's say third is your last node. Here it won't be pointing to the null to indicate that this is the last node. Here it will be pointing to the first node. Right, now how do you identify, because let's say you are traversing a circular linked list, how will you identify that this is the last node? Instead of checking that it is a null sign, you will be checking that is it pointing to the first node or to the start node, because you know what is the start node, right? You have the start pointer here. So in sing and doubly, where you check basically the existence of null to identify if you have reached the end of the linked list. In circular, you check the existence of start null. You have started and you check that have you reached start point again. If you have, then yeah, that is the end of the circular linked list. You have traversed it completely, right? Now what about doubly circular? So just multiply doubly and circular, you will literally get doubly circular. So yeah, here you will have nodes that have my bad, three field. What did I do? Yeah, so here you have three field again, indicating that it's a doubly linked list, right? And how do you indicate that it is a circular linked list? You basically don't have a end. You again move it to the starting point, right? So yeah, here you go. This is your doubly linked list, and as usual, you will have your starting endpoint. So basically these are your four type of linked list that you are going to see in the linked list world. Now from the next video onwards, when we're moving to the coding part, we are going to actually code out all the operations on only single linked list. Why? Because this is the one that is most commonly asked in your questions. And truth be told, if you are aware of how do you create a single linked list and how you perform your insert delete operation in a single linked list, you can accomplish that in all the linked lists. Okay, and doubly, let's take an example, right? for singly, if the data if you create a structure, let's say in terms of C++, right, one is storing the data, one is storing the address, right? This is your single linked list. In Doubly, you only need to create an extra address field, right? This is your complete logic of Doubly, right? And since you already have the address of your previous in your next node, you are comfortable, you can traverse anywhere you want, right? In Circular, the only thing that's going to change is instead of checking for the existence of null, my bad, instead of checking for the existence of null, you will be checking for the existence of start node, right? And what about the Doubly Circular? Just combine both of them and you'll get Doubly Circular, right? So these are all type of a linked list, and yeah, that is all. In the next video, we'll be starting with the coding of all the operations. So yep, see you then. Thank you for watching.